Hello everyone, this is the video lecture for Pre-Calculus section 5.2. Trig Functions. By trig functions, I mean sine, cosine, and tangent. Now, I personally am going to use thetas, while they use t's. I'll of course use what the homework is using as we keep going. But there you go. Those are trig functions, sine, cosine, and tangent. They also will be talking about the other three. We got cosecant. I'll just use my theta, I guess, for right now. Secant and cotangent. Okay. I'm going to give you more definitions about these. I think they're really awesome stuff here. But sine and cosecant are related. Cosine and secant are related, and tangent and cotangent are pretty obviously related. Every function has a co, so sine has a cosecant, cosine has a secant, and tangent has a cotangent. So everyone's got a co somewhere in there. So there you go. Okay, what are the definitions of these? Well, it's funny that the homework actually starts with you defining what they are. So they say sine of t is equal to what? Cosine of t is equal to what? And tangent of t is equal to what? Now, I agree with what they're going to do here, but it's also, I think, a little bit, it's not enough. It's too little. But let's go through it. It's fine. Your answers for these are kind of obvious. In fact, here's an interesting thing here about the homework. Let's just say that you have this kind of question, you have no clue what the answers are. Well, just get it wrong 3 times, and they'll give you the answers. This thing doesn't randomize. So, new randomization, nothing has changed. Retype your answers, and you're done. That happens very often, especially on these first couple of questions in each section, because they're trying to teach you or review you or something like that. Anyways, sine equals y, cosine equals x, and tangent is y over x. I'm going to go a little bit further on some of this. Like this guy right here, y over x, I'm also going to say slope. I really like that. Slope is really cool. Y and x are good, but in particular, if you're wanting to go like true ratios, it's y over r and x over r. I think what they're trying to do here is say, on the unit circle, what do we got there? So if you have a point, I'm just going to make something up, square root 3 over 2 comma half, let's say, okay? This is the point at 30 degrees on the unit circle. That's not concerning me. They're just saying, hey, what would be my sine given, yeah, actually, I guess I could just use sine 30. What would it be? Well, it's the y value, which is right here. This is x and y. It's the y value, so literally 1/2. Hey, what's your cosine at 30? Well, it's your x value, so it's that guy right there. Done. Super easy. What's your tangent? This is just a little example on the side, by the way. What's your tangent? Well, it's y over x, so I'm going to take my y divided by my x, and in WebAssign, you don't actually have to simplify, so leave it alone. You could cancel the 2's. This is totally appropriate. This is another way you can write it. These are all correct, okay? You don't need to simplify. It's up to you on how you want to do that. So you can see that from unit circle stuff, like we got that from unit circle, this guy right here, 30 degrees, there you go. You can find your sine, cosine, and tangent very quickly. So that's kind of what they're going for. I'm just going to keep on going. So I'm going to reference the unit circle often. And sometimes, maybe in the future, I'm going to just try to do it off of memory so that you can see that it's important to do this for memory. But in the meantime, I think it's not hard to just pull up the unit circle. So 3 pi over 4 is right there. Notice that we got an x and a y. X and a y. Well, what are they looking for here is cosine, which is x. So the x value at 3 pi over 4. So negative square root 2 over 2. See how that works? Cosine at 5 pi over 4. Again, the x value at 5 pi over 4. 5 pi over 4 right there. They want the x value because it's cosine. So, negative square root 2 over 2 again. Okay. And so on and so forth. There's more to it. 52010. So part A, they say find the sine at 3 pi over 4. Remember that the sine is a y value. So I go to 3 pi over 4. Looking at the y value this time, that's a positive square root 2 over 2. Part B, I guess they're all just a whole lot of divide by 4s. So fascinating. It's okay. Once you memorize it, it's actually a little bit more fun. So 9 pi over 4, where's that? Well, I don't have a 9 pi over 4, but if you notice, I got 1 pi over 4, 2 pi over 4, technically 3, 4, 5, 6, 7, 8, 8 pi over 4. 8 over 4 is 2, right? See it? 9. I counted it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could say that 45 degrees times 9. So I went around one full loop, and then I got one extra little bit here. So I'm supposed to be basically sitting right here, quadrant 1. Like right here. I went around, and a little extra. Well, sine is the y value. The y value here is a positive square root 2 over 2. There you go. And again, there's probably more to that. 52014. This is where it gets a little interesting. So I got tangent at negative 3 pi over 4. Okay. First off, let me convert this over to degrees. So I'm saying 3 pi over 4 is right here. That's basically 135 degrees. So I'm saying tangent of negative 135 degrees. Well, where's negative in comparison to positive? So negative is going down this way. Notice that it's basically over here. Well, negative would be down over here. So you were going this distance. So it would end up being at the 225 mark. So like if I were to draw this out, it's this guy right there. What's my tangent? Well, remember that tangent is y over x. Y over x. Well, my y value is a negative square root 2 over 2. My x value is a negative square root 2 over 2. Negatives cancel, square root 2's cancel, divide by 2's cancel, you get a 1. Just 1. 1. That's your answer. Just 1. Cosecant. Now, this is where it kind of gets a little different. Obviously, we don't have just a plain old sine, cosine, or tangent here. And I haven't yet taught you what cosecant even means. Well, let me let's do a little thing on the side here. My cosecant is 1 over sine. My secant is 1 over cosine. And cotangent is 1 over tangent. Now, before I keep going, there's something missing here that you might notice if you're kind of picky like me. There's no t's, there's no thetas, there's no angles. I didn't write them, and I want to show you that we're just talking generalities here. Is it proper and true to put a theta on each one of these? Well, yeah, I should. As your math teacher, I was just being lazy, and I should have done that. But I understand you. I understand you without you putting a theta, and you probably understand you without always putting a theta. The core of it is that we have cosecant is 1 over the sine, which is 1 over the y value, right? Secant, 1 over cosine, 1 over your x value. Cotangent, this is basically 1 over y over x, right? Because my tangent's y over x in the bottom. But whenever I flip it, I should get x over y now. So that's my new formulas for each one of these guys here. Okay? I'm not picky about thetas and stuff. I just want to get the formula. What is the formula? Well, then, so what I'm saying here is that this is 1 over the sine at negative 3 pi over 4. Okay? And that's what I'm looking for. So if I find the sine value, the y value at this angle, then I could just toss it in 1 divide by and whatever. So where is negative 3 pi over 4? 3 pi over 4 is right there. Negative, again, we would go positive, so negative's down over here at the 225 mark. We're looking at a y value. The y value is negative square root 2 over 2. And so in all reality, it's 1 divided by negative square root 2 over 2, all in the denominator there. I know that it looks a little sloppy. And that should be okay for WebAssign. You don't have to use the parentheses. I think they'll understand. Just as long as you got big division. Okay, don't mistake that, at least. You could simplify, toss the 2 in the top, rationalize denominator, whatever you want to do. The answer actually ends up, if you simplify it, as negative square root 2. It's kind of funny how that works. Super easy. But there you go. So now we got our formulas. And now you can see how we're using them. 52017, same thing. Part A says we got cosecant at 11 pi over 6 is equal to what? Well, we already know that this is 1 over the sine. It's 1 over the y value at the 11 pi over 6. See, I'm not putting a theta here. I probably should at least put a theta. I don't know. It doesn't matter, honestly. So 11 pi over 6 right here. My y value is right there, negative 1/2. And so I'm saying 1 over a negative 1/2. You know what would happen here, right? So the 2 can flip up. You got a negative there, so it's negative 2. You don't have to do that. It's up to you. Part B. Secant negative pi over 6 is equal to what? Well, secant is 1 over cosine. That's 1 over the x value. So I'm looking for the x value now at negative pi over 6. I don't have a negative pi over 6, so I got a positive. They're basically saying 30 degrees, but now not 30 degrees, but a negative 30 degrees down over here. So negative 30 degrees, we got our place, we got our point, and I'm looking for the x value. It's square root 3 over 2. So I got 1 over square root 3 over 2, and that was a positive value. Again, you could just answer it just like that if you simplify it even a little bit. 2 over the square root of 3, that's cool. If I can make my 3 look a little bit better. Another way is 2 square root of 3 over 3. That's another way. These are all great. It doesn't matter as long as you're getting the right answer. Okay. Just a couple more of these. So we got 52026. I got t, again, theta, my angle, is equal to 3 pi over 2. And they want to know, what is the sine at t? What is the cosine at t? What's my tangent at t? Okay, this is an interesting one. So 3 pi over 2, if you go to the unit circle, it's right here, 270 degrees. And so you can see I got my x value, my y value. Okay, cool. So let's go start putting those in. So this was looking for a y value. That would be a negative 1. This is the x value. Just put in 0. And tangent is y over x. So negative 1 divided by 0. Okay, now what is that? That's undefined. What you do in WebAssign is undefined. Hit the caps lock and start typing. That's what they're wanting. That is their answer. Just type it out. Now, I think they're actually asking for the other 3 as well. And this is not hard at all, so I'm going to show you. It's super easy once you have these 3. Cosecant of t is 1 over the y value, so 1 over negative 1. Again, you definitely simplify if you want to. Secant of t is 1 over x, so 1 over 0. Uh-oh. Again, undefined. Much easier to type it. And then cotangent of t is now x over y. Well, x over y, 0 over negative 1, well, it's just a 0. Okay. Pretty easy, pretty easy. 52031. I have a point, negative 2/5, comma, square root 21 over 21, all over 5. And they want the sine, cosine, and tangent for this guy here. Now, I'm supposing that this is actually on the unit circle. Otherwise, I don't know why it's in this section. But okay, let's just assume that it is. I'm pretty sure it is. It's on the unit circle. Therefore, simply put, y, and so then I got square root 21 over 5, x, just negative 2/5, and then y over x, so I got square root 21 over 5 divided by negative 2 over 5. That would work. You can cancel your 5s and make it just a little bit nicer at least, though. That's much better. All right. Let's do some more interesting stuff. So 52049. I got sine of t is less than 0. I've got cosine of t is greater than 0. Now notice these t's are actually the same. I don't know what t is. I don't know what the angle is, but I got the same angle for both of these guys to make this work. And they're saying, what quadrant does that work in? Quadrant 1, 2, 3, or 4. So when they're saying sine is less than 0, what they're saying is that y is less than 0, y is negative, while cosine being greater than 0, they're saying x is greater than 0, x is positive. X is positive, y is negative. We're down here in quadrant 4, and that's your answer, just quadrant 4. 52055. This time they're saying, hey, we're in quadrant 4. Okay, thanks for telling me. My V's are looking a little bit bad. That's a V. They say using sine of t, we need to write the formula for tangent of t. Now this is just a strange question. And I'm going to be straight with you. This is the kind of question where I go and try it once, I don't get it, and then I just go ahead and do it 3 times, get it wrong, look at what they're saying. And I don't think it's randomized. If it is, it's very little. What are they even looking for? What are they asking for here? Well, they're saying that tangent t can be rewritten only using sines and cosines. Well, first, let's just start thinking about this in formula form. We got y over x. You know the funny thing is, though, that y is the same as sine. X is the same as saying cosine. So here we just made a new formula, I guess. Tangent is sine over cosine. And that's a legit formula, by the way. Very good formula. I definitely like using that. But this is not good enough because I need to use just sine. That cosine there is not correct, technically. This is a correct statement, but it's not what WebAssign's looking for their answer here. Again, just between you and me, if you say tangent equals sine over cosine, you get an A+. Plus, because that's perfect. That's awesome. I love it. But WebAssign is saying they want it in terms of only sine, and that's fine for them. This is not a formula I ever use, so we're just doing what the homework says. I'm happy if you've learned at least this much. So what are they wanting? They're wanting to replace this cosine here. Now, let's go back to a formula here. We got x squared plus y squared is equal to r squared. Well, we're talking unit circle here, I hope. So I could just say a 1. We already talked about it in the last section. Well, I can rewrite this as cosine. Ooh, I don't want to use x there. I'm sorry, t, because then it looks weird. And sine equals 1. So cosine squared plus sine squared equals 1. That's still Pythagorean theorem. I'm just replacing it with x and y, cosine and sine, just like I did right here. Well, let's say I want to solve for cosine. So I'm going to move my sine over. So I got this formula now. Cosine by itself, I got to square root both sides. No more square there. And so this is plus or minus. It's plus or minus. Remember that. It's actually very important to know that on this problem here. Cosine can be replaced with this formula here. So next step would be saying sine of t divided by plus or minus the square root of 1 minus sine. Oh, that's a square. Sorry, I just didn't write it. My bad. Sine squared. So this is almost your answer, but the plus and minus doesn't work. Notice they were talking about quadrant 4. Quadrant 4. Well, quadrant 4 is down here, and we're talking about tangent. They're saying this whole thing is equal to tangent. Is my tangent down here negative or positive? That's kind of the question. Is my final answer going to end up negative or positive? Well, what happens is that this tangent here is actually going to be negative because tangent was equal to slope. That was way back there. Y over x, slope. My slope of that line that you're seeing right here, this is a negative slope. It's going down. It's going down over time. So I got a slope that's negative. I need to get this answer here negative in the end. So your first thoughts are saying, oh, well, then we got to put a minus sign. It's plus or minus. Which one? It's a negative, right? Totally cool. Well, that is a wrong statement, actually. You know what's so weird? It's the positive. Let me tell you why. Very, very weird how this works. This is the correct answer. Why did they choose a positive instead of a negative? I thought it was going to be a negative answer. Well, I'm going to ask you, down here in quadrant 4, what is your sine equal to? Well, your sine is less than 0. Your sine is negative. This guy in the numerator, that's a negative number. And so, in order to have a negative overall, if I had another negative sign here, that negative and this negative would cancel one another, and I'd actually have a positive. That's not what I want. I want a negative. And so instead, I have a negative in the top, a positive in the bottom, negative in the top, positive in the bottom. What do you get? You get a negative. Okay? So that's what the idea is. If that was confusing, trust me, it is confusing. It's very confusing. Just type this answer and get an answer. So good enough for now. But think about it for just a little bit, okay? You're looking for a negative answer. Sine is already negative. And so how do I answer it in order to get still an answer that's negative? And that's a negative answer right there, technically. Okay. Blah, blah, blah. I think I only have a couple more questions left. Four more questions, actually. But they're really small. 52063. They say that sine of t is equal to negative 5/13. And then we're in quadrant 4. Now this is a classic problem here. You can't go through PreCal without having this. And so we got to have it. And we'll do the rest here in a minute. So I need to find my cosine and my tangent here. We're in quadrant 4. We got sine is negative. So we're down over here. I got this guy here. I need to find cosine and sine. Well, remember that cosine is equal to the square root of 1 minus sine squared, right? Negative, positive, we'll talk about that here in a minute. I just want to plug the thing in and get a number. So let's get a number. Plugging that in. I got, what, 25 over 169? Oh, I should just use a calculator on this stuff. 1 minus 25 over 169. Yeah, I think I saw this earlier in another, I think it was the previous recording. I have a 12 over 13 when you square root both of them. Got my number. Notice here that I have I'm in quadrant 4, okay? So quadrant 4, cool, is my answer here positive or negative? I mean, technically, it's a plus or a minus right here in the front, right? So is it a positive or a negative that we're wanting? Well, notice here, x is positive, right? So this is going to be positive for sure. Cosine, again, this is x, is going to be a positive 12 over 13. This is my y value. Tangent is y over x. Now that I got x and y, I can just put them over one another. So y over x. Notice that my 13s are going to cancel. Leaves a negative 5 over 12. Awesome. So now we're going to take these 3 and we're going to flip them to find the last one. So cosecant of t is 1 over sine. 1 over the y. Already got my y. Basically, I'm just going to take this guy and flip it. Yes, I know basically we're doing this guy here, but what I'm really doing is just flipping it upside down. Secant of t, 1 over cosine of t, 1 over x. I already have my x. My x is 12 over 13, so now it's 13 over 12. Just flip it upside down. Cotangent, 1 over tangent. I guess you can also say x over y if you really want to. not too concerned about that. We're just going to take our answer for tangent and flip it upside down, so negative 12 over 5. Notice that they retain the same signs. Okay, so negative, positive, negative, negative, positive, negative. Okay, 5, 2, 080. Okay, so I think this is actually a word problem here. B of t is equal to 80 plus 2 times the sine of pi t over 12. And they see that t is the hours after midnight. Hours after midnight. To me, after midnight, so like you're saying 0500 is, well, 5 a.m., 5 hours after midnight. That's kind of what I'm thinking. And so they're saying, okay, part A, 2 a.m. Yeah, 2 a.m. Well, that's going to be t equals 2. That's super easy. I'm going to plug that in. So B is equal to 80 plus 2 times the sine of pi times the 2 all over 12. Calculator, you actually get 81. So there you go. One thing about this is when I put this into the calculator here, you need to make sure that you're in radian mode. Okay, so if you have a calculator like a TI or something, push the mode button, go to radian mode. If you got it like a Casio or something, go to setup and all that kind of stuff. Okay, so part B, we got 10:30 a.m. And so that would be t equals 10.5. Plug it in just like what we did last time. I got 80.7653. Awesome. Again, you're just using calculator here. Super easy to do that. Make sure it's in radio mode. If you're getting answers different than this, then you're in degree mode, and you have to change it to radio mode. We can change it back to degree mode later. So it's just something that you flip-flop all the time. F of x. These are the last two questions. They're kind of different than the rest. So I got x to the fourth times cosine of 2x. And they're saying, is this even, odd, or neither? Now, it's been a long time since we talked about even, odd, or neither. Even is symmetric about the y-axis. It should be the same on both sides. Odd is symmetric about the origin. So it's kind of like they're opposites of one another. Tick, 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 tick. Eventually you get to the same thing again. Origin, it's like a clock. It'll go around in a clock and you'll come back to itself eventually. And neither is just neither. Neither one of those, okay? What I often look for is I look at the powers. Okay? That's pretty important. But also I want to tell you that my cosine is an even, my sine is an odd, and I'm pretty sure that tangent is an odd. I'm not gonna talk about tangent. He's not gonna be part of the questions here. If they were saying, hey, give me even or odd for tangent, I'd say odd. But because the graph is a little weird, I'd have to give you a domain restriction, all that stuff, whatever. So, is this even, odd, or neither? Even, odd, or neither? What do you think? Well, first off, look at the powers. You can see that's an even power. Cosine is even. So we got even, even. It's got to be an even. If you had even and odd together, then you would say neither. Okay? So just watch out for that. You can't have both. Last one, I got sine of x times cosine of x. And they're saying, is this even, odd, or neither? Okay, this one was a strange one for me. Apparently, the answer is odd. Whatever that means. I'd almost have to look at a graph to make sure why that works. So yeah, if you're a little much in doubt, I would graph it and see, is this symmetric about the y-axis? That would be an even. Is it symmetric about the origin? Something kind of like this. That'd be odd. So this is even or odd. I can't tell you immediately why this is odd, or even if it's correct. I don't know. It says odd. I'm going to keep it. Good enough for now. I think that's it. Yep, that's it. So, we're done. Thank you very much. Have a great day.